Hey everybody, today's lesson for geometry is from Unit 4.1 and the lesson number is number 6, and we will be looking at ways to find volumes of pyramids and cones. First we're going to start with a theorem which gives us the formula for finding the volume of a pyramid. The volume V of a pyramid is V equals 1/3 times capital B times H, where capital B is the area of the base and H is the height of the pyramid. Well, first of all, a quick lesson in drawing a pyramid. If you draw just a small parallelogram, you can even make it a rhombus. In this case, we will make it look like a rhombus, but our base will be a square in this particular instance. To make it into a pyramid, choose a point above and then connect that point to all 4 vertices of your base. And what we have here is a square-based pyramid. The height will be the perpendicular distance from the top of the pyramid to the base. And if we are given that that height is 6 inches, and the sides of the base are each 4 inches, meaning the base is a square, we can find the volume of this particular pyramid by doing 1/3 times the area of the base. Remember, this base is a square, so it's 4 times 4, or 16 inches squared. So we're going to plug 16 in for B, and our height is 6. Now, take and multiply that 16 by 6. We're going to end up with 96. And when we take 1/3 of that, we'll have 32 inches cubed. Remember that volume is in 3 dimensions, so it has to be measured in cubic units. Next, we'll take a look at the theorem for the volume of a cone. The volume V of a cone is V equals 1/3 times the area of the base times the height. You might say, well, what's the difference between this and the volume of a pyramid? Well, remember that a cone has a circular base. So to draw a cone, we actually draw an ellipse or an oval and then connect to a point up above. So the height would be drawn in perpendicular to the base. And then that base, again, is a circle. So it has a radius. So volume of a cone really could be written 1/3 times pi r squared, because that's the area of that circular base, times the height. So let's say if h equals 6 and r equals 4 centimeters, so they're both in centimeters, let's find the volume of the cone. So volume would be 1/3 times pi times 4 squared times our height of 6. Okay, next simplify it a little bit. Oops, sorry about that. Volume will be equal to 1/3 times pi times 16 times 6, or volume equals 1/3 times pi times 96. And if you take 1/3 of 96, again we get 32. Then we need the pi on the end, and we need centimeters cubed, because again it's a volume, so it needs to be in cubic units. Now, this is an exact answer because it's left in terms of pi. If you multiplied it out using your calculator, you would get approximately 100.5 centimeters cubed. Okay, next we'll do a few examples. It says that we're to find the volume of the pyramid with a triangular base and a height of 9 centimeters. Okay, so volume equals 1/3 times the area of the base times the height. So we need to find the area of this triangle. Okay, so the base is a triangle. Formula for finding the area of a triangle is 1/2 times base times height, little b this time, times height. So we're going to do 1/2 of 4 times 6. 1/2 of 24 gives us 12 square units. Okay, we're going to plug this in to our formula for volume. Say 1/3 times 12 times the height of 9. Okay. So in there, I might choose to do 1/3 of 12 first, right here, just to simplify that. 1/3 times 12 would give me 4. Then multiply by 9, and we get a volume of 36 centimeters cubed. All right, number 2, our second example, it says find the volume of the cone. Leave your answer in terms of pi. And our height this time around is 4.5 centimeters. Radius is 2.2 centimeters. So it's a matter of knowing your formula. 1/3. Since it's a cone, the base is a circle. So we want to do 1/3 times pi times r squared. And then we'll multiply by the height. So plug in all the values that you know. So 1/3 times pi times 2.2 squared times 4.5. Now, it does say to leave it in terms of pi, so we don't want to multiply by pi on the calculator, but you can do everything else. Well, let's start with a decimal. So if you did 2.2 and squared it and multiplied it by 4.5, you would get 21.78. So we can switch up the order. We can do 1/3 times 21.78 times pi. Again, don't type the pi key or 3.14 in your calculator. Just do 1/3 times 21.78. So we would end up with 7.26 times pi. And because it's volume, it needs to be in centimeters cubed. In our final example, I left out that this is the height that's perpendicular to that diameter. So if the diameter is 14 feet, the radius would be 7 feet. And what we need to do in here is solve for the height first. Because if we're going to find the volume, we're going to be doing 1/3 times pi r squared times the height. We have the radius, but we need the height. To solve for the height, we're given a clue that this angle is 32 degrees. Again, if the diameter is 14 feet, the radius has to be 7 and 7. So we need to use trig, okay, to solve for the height. So I can say the tangent of 32 degrees is equal to the opposite side of 7 over the adjacent side, h. Okay, cross multiply, we get h times the tangent of 32 is equal to 7, and therefore h is equal to 7 divided by tangent of 32. All right, we're going to leave that in its exact form. We're going to plug everything into our volume formula. So we're going to have volume equals 1/3 times pi times 7 squared times 7 divided by tangent of 32. And this is really crazy messy. You can simplify it a little bit, but I think we'll just go ahead and type this all into the calculator and round the volume to the nearest tenth. And you should get 574.8 feet cubed. So it's in cubic feet, again, because it's a volume. Okay, as always, good luck on the CYU and the homework. Speak up if you have any questions.